Hey guys, welcome to the last lesson of Chapter 9. This is it. After this lesson and the work that comes with it, we'll be doing review to get you ready for the Chapter 9 test, and we'll be done with this year. So let's get started. This should be a short video because we've only got two problems. First problem here is 9-101. Review what you learned about systems of inequalities in lesson 9.4.1 by graphing the system of inequalities at right on graph paper. Carefully shade the region of points that make both inequalities true. Let's start by graphing this inequality. It's got absolute value in there, so I know that the shape of the graph is going to be a V. To get this function graphed, let's make a table of values. An xy table, let's put some negative and positive values of x in there. And to get the y values, I'm going to just plug in each value of x into this equation. Okay, so if I plug in -2 for x, I get, well, the absolute value of -2 is +2, and +2 plus 4 is 6. So that's 1 point that I can plot, -2, 6. Let's keep going. Let's plug in -1. The absolute value of -1 is 1, and 1 plus 4 is 5. If you plug in 0, the absolute value of 0 is 0, and 0 plus 4 is 4. If you plug in 1, the absolute value of 1 is 1, and 1 plus 4 is 5. If you plug in 2, you're going to get 6. Okay, so if we plot these points, -2, 6, -1, 5, 0, 4, 1, 5, 2, 6, we can see that V shape form. And because we have less than or equal to, when I connect these points, I'm going to draw it with a solid line. So solid line this way, solid line that way. And now we've got to figure out where we're going to shade. Are we going to shade on the inside of the V shape or on the outside? So let's pick a point and test it. Let's pick 0, 0. And I'm going to test 0, 0 by taking that original inequality and plugging in 0 for y and 0 for x. Let's see. The absolute value of 0 is 0, and 0 plus 4 is 4. Is 0 less than or equal to 4? It is. So 0, 0 is a solution for this inequality, which means that we're going to shade towards 0, 0. So I'm going to shade below this V shape. Okay, everything down here too. All right. Now let's graph this inequality. This is going to be linear. Let's rewrite it actually. Let's get y by itself. So add x to the other side. Divide everything by 4. I get y is greater than or equal to 1/4 x, because x divided by 4 is just 1/4 x, plus 1. Okay, so my y-intercept is at 1, and my slope is 1/4, which means that if I draw a slope triangle, I'm going to go up 1 and over 4, up 1 and over 4, and I'm going to connect these points with a line. The line is going to be another solid line because of this greater than or equal to symbol. So solid line. Again, because of the greater than or equal to. And now we've got to figure out whether we're going to shade below the line or above the line. Let's test 0, 0 for this inequality as well. To do that, we are going to take our inequality, and again, like we did before, we're going to plug in 0 for y and 0 for x. See, 0, well, this is 0, so I'm left with 1 on the right side. Is 0 greater than or equal to 1? It is not. Since 0, 0 is not a solution, I'm going to shade on the opposite side. So not towards 0, 0, not below the line, above the line instead. Let me pick a different color. Okay, everything above the line. And so there you have it. Our solution region is where we have that overlap. So not the green, not the orange, this like brown color that we got from the overlap. This is our solution region. Okay. Let's move on then to the second problem. 9-103 says, notice that each system of inequalities below contains the same boundary lines. On graph paper, graph the boundaries for the system on one set of axes. Then for each pair of inequalities, work with your teammates to decide which region is the solution if a solution exists. Be ready to share your conclusions with the class. Notice that for all of these, we have 2x plus 3, and then we also have 2/3. I said that wrong. 2/3 x plus 3. And we also have 2/3 x. So let's draw the boundary lines for all of these first. Okay. Let's draw the boundary line for 2/3 x plus 3. My slope is 2/3 and my y-intercept is 3. So I'm going to start at 3. And if I draw a slope triangle, I'm going to go up 2 and over 3. And draw a line through those points. That line is going to be solid because of the less than or equal to. And since that same line comes up in parts B and C, I'm going to draw these over here too. So going through 3. And last but not least, let's draw it over here. Oops. And they're all solid lines because of that less than or equal to or that greater than or equal to. Okay, so that part is done. Now let's graph 2/3 x. So my y-intercept in this case would be 0. It's going through the origin, but my slope is the same. I'm going to go up 2 and over 3 since my slope is 2/3 for my slope triangle. So what we're actually going to get in this case are parallel lines. Since I have the same boundary lines, let's draw those over here too. Okay, and that's that. Now all we've got to do for each part is figure out where we're going to shade. So because 0, 0 falls on one of my boundary lines. 0, 0 may not be the best point to test. Instead, let's maybe test, let's do, doesn't really matter as long as it's just not a point on one of the boundary lines. Let's pick, I don't know, 0, 5. So I'm going to test the point 0, 5 for the first inequality here in part A to figure out where I'm going to shade. So I'm going to plug in 0 for x and 5 for y. Simplify. 2/3 times 0 is 0, and 0 plus 3 is 3. Is 5 less than or equal to 3? It is not. So that means that we're not going to shade towards 0, 5. We are going to shade the opposite way. So I'm going to shade below this pink line. Now let's test a point for the other inequality to see where we're going to shade for that one. So my inequality, my second inequality was y is greater than or equal to 2/3 x. Let's test the same point, 0, 5. So plug in 5 for y, 0 for x. Simplify. 2/3 times 0 is 0. Is 5 greater than or equal to 0? It is. So we are going to, for the blue line that I've drawn, we are going to shade towards 0, 5. So we're going to shade upward. So where is the solution region here? It is between these two parallel lines. The overlap is in between these two lines, the solution region. And since both lines are solid, the solution region does include the lines themselves. Okay, so we're done with part A. And I don't have to use, I don't have to test points in this case because I can use context clues from the inequalities to graph. Similarly to the previous lesson, 9.4.1, I know that if from part A to part B, this inequality is the same, the inequality symbol has stayed the same, then for this first inequality that's drawn in pink, I'm still going to shade below the line. But since this inequality symbol has flipped, then instead of shading above the blue line like I did before, I'm also going to shade below it. So shading below the blue line. Now my solution region is down here. Everything below that blue line and including it. Okay, similarly for part C, from B to C, this inequality symbol has stayed the same. So for that inequality drawn in blue, I'm going to shade below the line like I did in part B. But now that this first inequality has flipped symbols, it was less than or equal to before, now it's greater than or equal to. Instead of shading below that pink line, now I'm going to shade above it. In this case, because there is no overlap, there is no solution region. This means that there is no point that you can plug in that will make both inequalities true. Okay, so that's it. If you have any questions, please send me an email and have a terrific day.